In this lecture, we will discuss the assignment problem to determine optimal job assignment and cost of assignments by applying the Hungarian method. This is the cost matrix and given the 5 jobs, that is 1, 2, 3, 4 and 5, and 5 mechanic persons, that is A, B, C, D and E. Let's see the solution. In the Hungarian method, phase 1 is the row and column reductions. So in the phase 1, first step is subtract the minimum value of each row from the entries of that row, and second step is subtract the minimum value of each column from the entries of that column. First we will go for the row reduction. For this, we determine the minimum value from the each row. For the first row, minimum value is the 2, and for the second row, minimum value is 2. For the third row, minimum value is the 2. For the fourth row, minimum value is the 2. And fifth row, minimum value is the 6. Next, subtract these row minimum values from the respected rows. Then cost matrix will becomes the, so for the first row, 10 minus 2, it will become the 8. 3 minus 2, it will become the 1. And 3 minus 2, 1. 2 minus 2, 0. 8 minus 2, 6. In the second row, minimum value is the 2. Then 9 minus 2, it is the 7. 7 minus 2, it is the 5. 8 minus 2, it is the 6. 2 minus 2, it is the 0. 7 minus 2, it is the 5. Similarly, for the third row, minimum value is the 2. Then 7 minus 2, it is the 5. And 5 minus 2, it is the 3. 6 minus 2, it is the 4. 2 minus 2, 0. 4 minus 2, it is the 2. And for the fourth row, minimum value is the 2. Then subtract this 2 value from the fourth row, that is 3 minus 2, 1. 5 minus 2, 3. 8 minus 2, 6. 2 minus 2, 0. 4 minus 2, 2. Similarly, subtract the minimum value 6 from the fifth row, that is 9 minus 6, it is the 3. 10 minus 6, it is the 4. 9 minus 6, it is the 3. 6 minus 6, 0. 10 minus 6, it is the 4. Next we will go for the column reduction for a modified cost matrix. So first we have to determine the minimum value in the each column, that is in the first column minimum value is the 1. In the second column minimum value is the 1. In the third column 1. In the fourth column 0. Similarly, in the fifth column minimum value is the 2. Then subtract the minimum value in each column. Then first column becomes the 8 minus 1, it is the 7. 7 minus 1, it is 6. 5 minus 1, 4. 1 minus 1, 0. 3 minus 2, it is the, 3 minus 1, it is the 2. Similarly, in the second column, we have to subtract the minimum value 1, that is 1 minus 1 is the 0. 5 minus 1, 4. 3 minus 1, 2. 3 minus 1, 2. 4 minus 1, 3. Similarly, in the third column also we have to subtract the minimum value 1, that is third column becomes the 1 minus 1, 0. 6 minus 1, 5. 4 minus 1, 3. 6 minus 1, 5. 3 minus 1, 2. Similarly, we have to subtract the 0 from the fourth column. Obviously, here all are having the 0, then it will be not changes. So all values will be same only, 0, 0, 0 and 0. Next we have to subtract the value 2 in the fifth column. then fifth column becomes the 6 minus 2, it is the 4, 5 minus 2, it is the 3, 2 minus 2, 0, and 2 minus 2, it is the 0, and 4 minus 2, it is the 4. After the row and column reductions, next we will go for the phase 2 to optimization of the problem. In this, first step is draw a minimum number of lines to cover all the zeros of the matrix. For this, first we have to go for the row scanning and we have to start with the first row. And we have to observe, is there exactly one zero? Then we have to mark a square around that zero and draw a vertical line which is passing through that zero. Otherwise, we have to skip the particular row. So in the first row, we are having the 2 zeros. Then we have to skip the first row. Then observe the second row. In the second row, we are having the only 1 0. Then we have to mark a square around the 0 and to draw a vertical line which is passing through that 0. Next we have to go for the third row. In the third row, we are having the only 1 0. This 0 already we are removed. So here also we are having the exactly 1 0. Then we have to square a mark around this 0 and we have to draw a vertical line. Next we have to go for the fourth row. In the fourth row also we are having the only exactly 1 0. Then we have to square a mark around that 0 and we have to draw a vertical line. Next we have to go for the fifth row. So in the fifth row, here there is no zeros, then I have to skip this fifth row. After the scanning of the last row, we have to check whether all the zeros are covered with the lines. If yes, then we have to go for the step 2. Otherwise, we have to go for the column scanning. Here, 2 zeros are not covered with the lines, so we have to go for the column scanning. So in the column scanning, first we have to observe is there exactly 1 0? Then we have to mark a square around the 0 and draw a horizontal line which is passing through that 0. Otherwise, we have to skip that column. So first we have to observe the first column. So first column already we are removed. Then we have to go for the second column. In the second column, we are having the exactly 1 0. Then we have to square a mark around the 0. Then we have to draw a horizontal line which is passing through that 0. Next we have to go for the third column. Here there is no zeros. Then we have to skip this column. Next already fourth column and fifth column we are removed. Then we have to observe after the scanning the last column, once again I have to check whether all the zeros are covered with the lines. So here all the zeros are covered with the lines. Then I have to go for the second. So second step is check whether the number of square marked is equal to the number of rows of the matrix. If yes, then I have to go for the step 5. Otherwise, we have to go for the step 3. Here, square marked zeros are the 4 and the number of rows are the 5. Then, square marked zeros are not equal to the number of rows. Then we have to go for the third step. The third step is identify the minimum value of the undeleted cell value. So, these are all the undeleted cell values. Among these values, we have to identify the minimum value. So here, minimum value of the undeleted cell is number 2. Then we have to add this minimum undeleted cell value at the intersection points of the present matrix. Intersection points is which is passing the horizontal as well as the vertical lines. So in the cost matrix we have to observe 7, 0 and 4 cell values are passing the horizontal line as well as the vertical line. So these values we are calling as the intersection points. So in the third step, so first one is we have to add this minimum value at the intersection points. So now this minimum value is the 2 and we have to add this 2 value for the intersection points. Then cost matrix will become so 7 plus 2 it is the 9 and another intersection point is the 0, 0 plus 2 it is the 2, another intersection point is 4, then 4 plus 2 it is the 6. So next one is subtract the minimum undeleted cell value at the undeleted cell values. So these are all the undeleted cell values. From these all values we have to subtract the minimum value of the undeleted cell value. That is, we have to subtract the 2 from these all the elements. Now 4 minus 2 it will become the 2 and 5 minus 2 it is the 3, 2 minus 2 it is the 0, 3 minus 3 it is 3 minus 2 it is the 1, 2 minus 2 it is the 0 and 5 minus 2 it is the 3, 3 minus 2 it is the 1, 2 minus 2 it is the 0. So next one is all other elements should be the same. So remaining elements we should not to change. This is the modified cost matrix and next we will go for the step 4, that is go to step 1. So once again we have to repeat the same procedure. First we will do the row reduction. For this identify the minimum value from each row. That is, in the first row minimum value is 0, in the second row minimum value is 0 and in the third row minimum value is 0 and in the fourth row minimum value is 0. Similarly in the fifth row also minimum value is the 0. Here observe that when all the rows are having the minimum value is 0. Then we subtract this minimum value from the rows, we will get the same values in all the rows. Then no need for the row reduction. Next we have to go for the column reduction. First we have to identify the minimum value in each column. So in the first column minimum value is 0. Similarly in the second column minimum value is the 0. Third column also minimum value is 0. Fourth column also minimum value is 0. Similarly in the fifth column also minimum value is the 0. So here also all the columns are having the 0. Then after column reduction we will get the same values in all the columns. Then no need for the column reduction. So next we have to go for draw a minimum number of lines to cover all the zeros. For this first we have to go for the row scanning. In the first row we have to observe the 2 zeros are there. Then have to skip the first row. And in the second row we are having only 1 0. Then we have to square a mark around that 0 and draw a vertical line. Next in the third row we are having the 2 zeros. In the fourth row also we are having the 3 zeros. Then I have to skip the third and fourth rows. In the fifth row we are having exactly 1 0. Then we have to mark a square around that 0. Then we have to draw a vertical line. So after the last row we have to check whether all the zeros are covered with lines or not. So here many zeros are not covered with the lines. Then we have to go for the column scanning. So for the column scanning first we have to start with the first column. In the first column we are having exactly 1 0. Then I have to square a mark and draw a horizontal line. Next in the second column we are having more than 1 0. Then I have to skip the second column. So third column already we are removed. Fourth column also we are removed. In the fifth column, we are having the only exactly 1 0. Then have to square a mark. Then have to draw a horizontal line. After scanning the last column, we have to check whether all the zeros are covered with the lines. Here 1 0 is not covered with the line. So then we have to go for the row scanning. So in the first row, here exactly only 1 0. Then have to square a mark. Then have to draw a vertical line. So here all the zeros are covered with the lines. Then have to go for the next step. Here we have to observe number of square marked zeros are equal to the number of rows or not. Here number of square marked zeros are 5 and number of rows also 5. Then n equal to n, that is the number of rows equal to the number of square marked zeros. So then we have to treat this solution as marked by the square as the optimal solution. Then once again we have to observe the given cost matrix. Then same respected positions we have to mark a square for the given cost matrix. Then the optimal cost assignment will become for the first job we are assigned the mechanic is D. So same thing here, for the job 1 we have to assign the mechanic D. Similarly for the second job we are assigned mechanic is A. So second job it is the mechanic A. For the third job we have to assign mechanic E. So third job we have to assign mechanic E. For the fourth job we have to assign the mechanic B. For the fourth job we have to assign the mechanic B. And similarly fifth job we have to assign the mechanic C. So fifth job we have to assign the mechanic C. Similarly we have to observe the cost of the respected marked positions. For the first job and mechanic D, cost is the 3. For the second job and for mechanic A, cost is the 3. And for the third job and mechanic E, cost is the 9. And for the fourth job and mechanic B, cost is the 2. And fifth job mechanic C, cost is the 4. Then total cost of assignment is 3 plus 3 plus 9 plus 2 plus 4 equal to the 21 rupees. So this is the solution, and thank you.